Welcome to Electric Fun. In today's class, we are going to discuss the problem based on controllable canonical form. For a given transfer function y of z by u of z, and we have to obtain the state space representation. So this is a given question, y of z by u of z equals to z plus 1 by z square plus 1.3 into z plus 0.4. So for this given transfer function, we have to find out the controllable canonical form and its state space representation. So first you have to write the state space representation for controllable canonical form. This is how to write, that is x1 of k plus 1, x2 of k plus 1, so on up to xn of k plus 1. That is equals to matrix A 0, 1, 0, so on up to 0, 0, 0, 1, so on up to 0. If it is of third column, then 0, 0, 0, 1, so on up to 0. So in this way, matrix A has to be represented. That is 0, 0, 0, so on up to minus an, 1, 0, 0, so on up to minus an minus 1, 0, 0, 0 up to so on minus an into x1 of k, x2 of k, x up to so on xn of k plus matrix B 0, 0, 0, so on up to 1 into u of k. Suppose it is of 2 by 2 matrix, then simply denote the matrix B as 0, 1. If it is of 3 by 3, then 0, 0, 1. And coming to the output equation, y of k equals to bn minus an b naught, and next term will be bn minus 1 minus an minus 1 into b naught, so on up to b1 minus a1 b naught into x1 of k, x2 of k up to so on xn of k plus b naught u of k. So this is how to represent the standard state space representation of controllable canonical form. Now let us solve the question. Given y of z by u of z equals to z plus 1 by z square plus 1.3 into z plus 0.4. Let us assume this is an equation 1. And this is a standard representation of transfer function for controllable canonical form as well as observable canonical form. So you have to remember this formula as well as this representation. So let us see this one, that is y of z by u of z equals to b naught z power n plus the next term will be b1 z power n minus 1 plus what will be the third term, b2 z power n minus 2, so on up to plus bn divided by z power n plus a1 z power n minus 1 plus a2 z power n minus 2 plus so on up to plus an. So this is as equation number 2. Now you have to compare equation 2 with the given question and find out the values required. So here in the given question, if you see, the order is 2, z square, z power is 2. So simply write down here the order is n equals to 2. So whenever order is 2, in the denominator you need to find out the values of a1 and a2. And in the numerator you have to find out the values of b0, b1 and b2. Suppose if n equals to 3. So in the denominator you have to find out the variables as a1, a2, a3. Coming to the numerator, you have to find out b0, b1, b2, b3. So in this way, we have to find a1, a2 values as well as b0, b1 and b2. So let us see how to find that values. Let us first compare the denominator equation. That is a1 z power n minus 1. Substitute n value, that is a1 z power n. N is 2. 2 minus 1 is 1. So z power 1 is z. That is a1 into z. a1 into z. Suppose if you compare this with the given question, what is this? Nothing but this is a1 into z. So what is a1 value? That is 1.3. Simply write it as a1 equals to 1.3. Next we have to find out a2 because order is n equals to 2. So we have to find out a1 and a2. So we have found a1. Now we'll find it a2. That is a2 z power n minus 2. a2 into z power, what is n value? 2. So 2 minus 2 is 0. So z power 0 is nothing but 1. Nothing but a2 into 1. Simply a2 into 1. So if you compare with this equation, this is nothing but a2 into 1. So this value is a2. Simply write down a2 value as 0.4. Now let us find out the numerator variables, that is b0, b1 and b2 we have to find. So b0 into z power n. So do we have any numerator power z power n? So we do not have any z power n. So simply write down b0 value as 0. Next term is b1 z power n minus 1. So b1 z power n minus 1. b1 z power, what is n value? 2. So 2 minus 1 is nothing but 1. So that is nothing but simply b1 into z. So b1 into z. So if you compare this, so we have z, the second term as z. So what is this one? What did we get? b1 into z. So what will be the value of b1 over here? Something into z. What will be the value? 1. So 1 into z is nothing but z itself. So we have found that it has to be like b1 and b1 into z. So we have only z. So what will be the automatic value of b1 here? If you multiply with 1 only, you will get z. So simply write down b1 equals to z. And next term, b2 z power n minus 2. So b2 z power n value is 2. So 2 minus 2 is 0. Something power 0 is 1. So simply you have to get b2 value. So what is that b2 value here? It is equals to 1. So b2 equals to 1. So we have got a1, a2, b0, b1 and b2. Now we have to represent in the state space representation. Let us write that since order is 2, we have to get 2 by 2 matrix itself. So x1 of k plus 1, x2 of k plus 1, that is equals to. Whenever it is 2 by 2 matrix, simply write it as 0, 1. First column element will be 0 and 1. And next column it will be minus a2 and minus a1. Because we'll see here, minus an, n value is 2. So minus a2. What will be the next term? Minus an minus 1. So what is n? 2. If you substitute 2 here, what will get? Minus a 2 minus 1. 2 minus 1 is 1. That is nothing but minus a1. So we have written as minus a1 into x1 of k, x2 of k. Plus, if it is of 2 by 2 matrix, simply write down the B matrix as 0, 1 into u of k. And coming to the output equation, y of k equals to bn minus an b0. What is n? 2. So b2 minus a2 b0. So we have written b2 minus a2 b0. What will be the next term? bn minus 1. 2 minus 1 is 1. So b1 minus an minus 1. a2 minus 1 is a1. a1 into b0 into x1 of k, x2 of k plus matrix D will be 0. So this is how to represent in the standard representation of a given controllable canonical form in state space representation. Now we have all values. We have a2 value, a1 value, b2 value, b0 value, b1 value. Just simply substitute all these values in this expression. We will get the required solution. Now we will see how to solve. So first we will represent this one. x1 of k plus 1, x2 of k plus 1 equals to 0, 1. We have written 0, 1. What is a2 value? It is 0.4. What is here? It is written as minus a2. So minus 0.4. And coming to the a1 value, it is 1.3. Minus a1. So minus 1.3 into x1 of k, x2 of k. Plus matrix B, it is 2 by 2. So simply write 0, 1 into u of k. And coming to our output equation, y of k equals to b2 minus a2 into b0. So what is the value of b2? Here I have solved. b2 minus a2 b0 equals to, what is the value of b2? That is 1 minus a2 value 0.4 into b0 value 0. 0.4 into 0 is nothing but 0. So 1 minus 0 equals to 1. So what did we get? This value as 1. So this value, how much we got? 1. Similarly, solve this value. b1 minus a1 b0. 1 minus 1.3 into 0, that is equals to 1. Same thing we have written. So here y of k equals to, what did we get? 1 and 1. So 1, 1 into x1 of k, x2 of k. And coming to the D matrix, it will be 0. This is how to solve the state space representation of a given problem in controllable canonical form. This is of 2 by 2. Suppose if it is of 3 by 3 matrix, then matrix A should be written as 0, 1, 0, 0, 0, 1. Here the second element is 1. In the second column, third element will be 1. And since the order is 3 by 3, n equals to 3, then we have to get a3, a2, a1. And what about the numerator? You have to get b0, b1, b2 and b3. This is how to solve the given question for any given order of the given equation. Right? You have seen here. If it is of third order, 0, 1, 0, 0, 0, 1. If it is n equals to 3, you have to get minus a3, minus a2, minus a1. And similarly b0, b1, b2 and b3. So this is how to solve the problem for controllable canonical form for a given transfer function and representing in the state space representation. So you have to remember this formulas as well as this formulas. Then only you can solve the given question. It is very easy. Practice once or twice. You will get it. Thank you. If you like, please like the video and share the video and also comment. Thank you.